everyone, this is Ochung-Hei Elroy and I'm going to talk about the demonstration of my project, the evaluation of a solar power solution of off-grid villages. For the project objective, we'll develop a solar power system or solution that fulfills the objectives below, which are cost-effective, sustainable, portable, and non-complicated. So this is the overall setup of the solar power system with two 18 volts and 300 volt thin film solar panels connected in parallel. Max output voltage is 22 to 24 volts and the data logger as an AC load and water pump as a DC load. There will be weather station and data logger stores weather data and power data. So let's talk about the scenario simulation. Compared to the developed solar power system with daily power consumption in ideal and the worst situation. So first, to make sure the developed solar power system is able to fulfill the TFC requirements, which are the basic lighting, water pump, smartphone charger, and laptop or modem. However, this part is not required for the common needs of the TFC requirements. Now let's talk about the scenario simulation of the ideal situation. So in the left hand side, we calculated the three-member family daily power requirement is 3120 watt-hour. Ideal situation of the system of the 6 hours of max sunlight duration times 300 watts, which is the maximum output power of the solar panel, and times 2 of the solar panels, which is 3600 watt-hours. For the worst case, we take the lowest solar panel voltage in January. We get the at most of 13.2 volts, around 1900 watt-hours per day. So in the three-member family, total daily power requirement is 1400 watt-hour, so it is able to fulfill, so we can fulfilled the objective of the sustainable of the system. Next, let's talk about the shipping suggestion for the TFC conditions. For the TFC requirement, they want to make the system modular and packed inside a luggage. This advantage is easy to apply to the surface trips, and it is able to hand carry for visiting other rural areas. However, due to the Hong Kong airport policies, the luggage bag size cannot be more than 22 inches tall, 14 inches wide, and 9 inches deep. Also, sharp-shaped objects that longer than 7 inches cannot be brought to the plane, and the components that contains batteries cannot be taken. Also, for the main setup, for the wrist, the main components of the system are too large for traveling by air. So the solution is to order the main components from the online store and ask them for shipping to the destination. So the overall budget for the essential tools that can bring on plane is totally around $3,000 per person. And the optional tools is totally around $2,480. There will be some suggestions that will change the weight of the battery array. And we will see that the total weight for the battery array we use in the project is 32 kg. For the pros, the system can still operate even one of the batteries is malfunction. For the cons, it is weight heavy for the 32 kg. For the second suggestions, we see that it weighs 28 kg. For the pros, it doesn't need complicated connection because it is just one battery, and it is lighter weight than the suggestion 1. However, it is expensive and the stocks will not always available on the market. And here will be the overall budget for suggestion 1 and suggestion 2 in Hong Kong dollars. For the risk assessment, there are 4 technical risks in this project, which are weather problem, typhoon, thunderstorm, environmental problem, animal problem, and technical problem, as TFC doesn't have staff with proper background about the electricity engineering. And for the project risk, there will be a damage of the solar panels. Thank you for your listening.